Good morning.
Good morning.
Good
morning.
Good morning. How are you all?
Good.
Tarek, you're still in bed? School started hours ago. Dana, you're at your grandfather's?
Yeah.
When did you go there?
Yesterday.
Oh, by car?
Yeah.
Very nice. How long did that take you?
6 hours.
Far, isn't it? Hagada, El Guna to Cairo. Is your dad there?
No, my dad, he had to go work.
I'm also in Cairo.
Who said that?
Hello.
Me,
Who's me?
Yusuf.
Yusuf M, you're in Cairo?
Yeah,
Oh, where in Cairo are you?
Tagamma.
Tagamwa.
in Marcelo.
Alex is in Masa Alam and Jana, where in Cairo are you?
I don't know.
I'm in Hurghada, guys. And tomorrow I will be going to El Guna. So if anybody wants to leave any work for me in reception, I will collect it.
I actually finished the weekly homework and I submitted it.
I saw that you submitted online. Something to give me at school, I'll mark it and return it.
Miss, I did all of the homework. I just have the crossword. Can I leave it tomorrow?
Yes, but Nadim, you have a lot of other work to give me. And I'm still waiting for
homework? Did you send the weekly homework on Google Classroom?
I did. I sent it yesterday on Sunday. Right, is everybody ready to start science?
We need the worksheet.
Yes.
No, you can do the worksheet after the lesson is over. So, today in science, we are going to be looking at irreversible changes. Now, this all falls into the topic that we are learning, properties and changes of materials. So we are going to be looking at irreversible changes. Irreversible means something that cannot be changed. So once it has changed into something else, it cannot go back to what it was before. So your learning objective today is I will be able to identify and explain irreversible chemical changes. Now, in your science books, or if you are doing it by computer, I would like you to put the date, and then, as per usual, the title, which is Irreversible Changes, which is on the beginning of the PowerPoint. And I would like you to write the learning objective. Now, please don't forget to underline the date and the title. Kenzie.
Yes, Miss. What if you're doing it by sheets?
The sheets are just activities.
So we do it either in book or on the computer.
Exactly. Some of you have told me that you can't print the worksheets. You don't need to be able to print the worksheets. You can write it out in your books, and it's amazing handwriting practice if you can do this. Mohammed.
Miss, what sheet do I need to open? The identifying changes or invertible changes?
No, for the lesson, you don't need any of the sheets. You do the sheets after the lesson is finished. Alex?
Miss, what is the title?
The title is Irreversible Changes. Okay? Then you put the date, which today is the 4th of May. And then you write the learning objective, which is I will be able to identify and explain irreversible chemical changes. Last question from Yusuf Muftah. Yusuf, I'm trying to unmute you. But Yusuf, for some reason, I cannot unmute. Right, let's start the lesson. By the end of the lesson, I will be able to identify irreversible chemical changes. I will be able to explain irreversible chemical changes. And I will be able to describe the new materials created in an irreversible chemical change. Okay, so we will discuss that further. If there's something you don't understand, you will be able to understand it at any time. Put your hand up if you have any questions for me. I will be able to see it and I will unmute you when I'm ready to take your question, but you need to listen to me. So let's start with the kitchen. When you are in the kitchen and you watch your parents cook, or you decide to cook something yourself, cooking is full of chemical changes, whether you notice it or not. For instance, when you bake a cake and you put it in the oven, it's just like a liquid, the thick mush. And then while it's baking, it rises, it rises, it rises, and it goes hard. This is because you have baked a cake and the cake has chemical reactions. So whether it's the baking powder or whether it's the heat, a chemical change has happened. And the kitchen is where our food is made and cooked. But did you know it is also the main place, the home to many, many scientific reactions? Now, when we finish this lesson, I would like you to click on this video and watch a young boy doing an experiment with an egg, okay? And during this video, you will be able to find out more about the science of cooking. Afterwards, after you have finished watching the PowerPoint and understanding it by yourself, I would like you to also do me a video of you frying an egg and telling me about what the chemical reaction is. So the video that you click on in this link is what your video should be like. And remember to add your explanations of why there is a chemical change, and if this change is reversible, can you change the egg back to what it was originally, or is it an irreversible change, as in that's it, the egg has changed and you cannot bring it back to what it was before we started. So Lucas, tell me what happens when you put a raw egg into a hot frying pan?
It starts to cook from, usually because you put oil or things in there. Well, I don't know, some people do that, but it starts to heat up from the heat underneath. And because it's heating up, it starts becoming the liquid, the yolk and everything starts becoming more puffy, and it isn't really liquid anymore. And then after some time, you can just flip it around and it won't be like water-ish.
So what are you telling me, that it goes hard?
Yeah, it goes harder. It's not the hard, like it's harder than liquid, but it's hard enough to you can hold it.
Okay, and now let's ask Basant. Where's Basant? I'm looking for you, Basant. Here you are. Basant, what do you notice when you fry an egg? I can't unmute you. Basant? Okay, I'm sorry, but I can't unmute you, Basant, for some reason. Somebody else had their hand up. Mohammed, what do you notice when you fry an egg? What changes do you notice?
That at first the white color, it's like see-through, but after you finish, it's not see-through. You cannot see through it. It's just white.
Exactly, so the clear part of the egg becomes white, and it's no
Miss, and
longer...
also, can I add effects to my writing?
Can you what?
Add effects to my writing in the computer.
Of course you can. Make it really nice and exciting. I love exciting work. Okay, so we noticed from Lucas, he said that the egg becomes firmer. It becomes a solid. And Mohammed notices that the clear liquid becomes white. All right, let's see what the rest has to tell us. So we didn't watch the video together, but you will be watching the video when the lesson finishes. And in the clip, in the video clip, you will see that an egg is being cooked. And you will notice how the egg changes. Many of you have probably fried an egg before, or you've seen your parents fry an egg. So you've seen how it changes. Ah, Yusuf Moftah, you are now unmuted. Tell me what you wanted to say. No? Right, you're on mute. So the eggshell is cracked and the raw egg pours into the pan. Do you remember when we cracked eggs at school? We poured it into a metal or a polystyrene bowl, and it was clear, gooey liquid with a yellow center. We all know what an egg looks like, and the yellow center is the yolk. So as the liquid egg, the white bit, and the yolk are heated, the egg starts to change, and the clear liquid egg becomes white. It becomes harder, it firms up, like Lucas said, and it becomes opaque white. So this white bit changes into a solid. The orange liquid egg yolk also solidifies, so it also becomes harder and it turns lighter in color. And I am going to choose Nadim. Where are you? To tell me what opaque means.
What does what mean?
Opaque. Can you remember what opaque means?
No.
Muting you. Who remembers what opaque means? Oh, year 5. We've done this. Ellie, you were the first to put your hand up. Ellie, tell me what opaque means.
Opaque means it's bumpy.
No. Anyone else? Oh, Alexandra.
You cannot see through it.
Exactly. Opaque means that you cannot see through it. It is no longer clear. It is something that has now stopped you from seeing through to the other side. Now, can everyone put their hands down? I will, oh, Kenzie, sorry, I didn't mean to unmute you. So opaque means something that you can no longer see through. So the heat has caused an irreversible chemical change to occur to the egg you have just fried. The cooked egg cannot be cooled and turned back into a raw egg. It has changed forever. It is no longer going to be a raw egg anymore because you have cooked it. And it is a chemical change because the new product has been made. And the new product in frying an egg is a fried egg. And it is irreversible because, as I said, it cannot be changed back to a raw egg. So once you fry an egg, that's it. It becomes a fried egg and it will always be a fried egg, whether it's in your tummy or still in the pan. You have fried the egg, a chemical change has happened, and it will always be a fried egg. So melting, freezing, evaporating, condensing, and dissolving are all examples of reversible physical changes. So Kenzie, tell me why melting, freezing, evaporating, condensing, and dissolving are reversible physical changes.
If it goes in water, it can harden again. Like if it, for example, dissolving, if something dissolves in, for example, a liquid, you can freeze it to be a solid.
Okay. Who else has that? Yusuf, if I can unmute you. Yes. Yusuf, why is it a reversible physical change?
Because if you melt ice, you can freeze it again by putting it in the freezer. The same thing for water. If you freeze it, you can melt it.
Yes. What about evaporating? No? Lucas, tell me.
About evaporating, you can make it normal again because the steam what comes out is made out of the water what was inside. So if you put something like a pan above it, you can catch the water, and if you make an angle, it will start sliding into whatever jar you want. And if you want, you can even make ice cubes with if you have enough water.
Exactly. Now, who remembers learning about the water cycle? Put your hands up. Oh, anybody that's the water cycle? Nuriye. I haven't heard from Nuriye in a long time. So you remember the water cycle? Oh, I can't hear Nuriye. Is there anyone else with their hand up? Oh, lots of people. Ellie. Ellie.
Yeah.
Do you remember the water cycle?
Yeah.
So tell me
We were talking about.
Tell me.
We're talking about how it turns to. It evaporates and then it.
It rains.
And then it turns to clouds, and then it turns back to water.
Exactly. So when things evaporate, it goes up to the clouds and it starts to rain again. And that is the same in this process of evaporation. Like Lucas said, if you hold a pan over it, it will drip back down. You will get water. Now, there is a picture on this slide of sugar lumps about to be dissolved into tea. What has this got to do with being a reversible change? Let's ask Yusuf Muftah. Yusuf M? No. Okay. Kenzie. Kenzie.
Yes? Sorry, I couldn't hear you.
Oh, can you tell me what the sugar lumps have got to do with reversible physical changes?
When the sugar lumps go into the tea, they dissolve in the tea, and then it evaporates, and then it can make it up again.
Exactly. If you leave it and you separate the materials, and that will be our next lesson, separating materials, you can get the sugar back. Okay? So you can get the sugar back to its original form. So these are physical changes because no new materials were created. And they are reversible changes because they can be changed back to how they were before, or you can change it back round. They can be reversed. So in the kitchen, let's go back to our kitchen, our beloved kitchen. Chemical changes involve reactants and products. Reactants are the materials that you start off with before the chemical change has happened. And the products are the materials that are formed in the chemical change. Lucas, tell me.
I just wanted to say, can I tell you a little bit more about
Tell me a little bit more about I didn't hear you.
the water cycle.
Yes, tell me more, tell me more.
First, what happens is that the ocean water usually, what happens is it evaporates into the air, then it turns into a cloud, and then the cloud goes somewhere and starts raining or snowing. And then once that reaches the bottom, if it's soil, the water will make it into the soil and go down like an underwater stream it's making, and it will go back into the ocean, and then it will all happen again.
Exactly, so it's like a cycle. And so the evaporation turns to water, and the water freezes and falls to the ground and becomes water again. So that is a reversible change. So the products are the materials that are found in the chemical change. What was the reactant and what was the product in the egg example? Can anybody tell me what caused the chemical change? Hands up. I like to see hands up. Why did the egg change from a runny liquid into a solid? What made it change? Luca.
I think that it made a change because there's a lot of heat on the stove. It starts having chemical reactions.
Okay, you say heat. What does Ellie say?
It's actually like I say the same as Luca because when the particles in liquid they heat, they get more solids.
Okay, so you guys are right. You are both telling me that the heat when frying an egg is what caused the chemical change. You are right. So here we have the egg. So the reactant was the egg. The product, after you put it in the hot oil or the hot butter or whatever you use, was the cooked egg, or as we call it, the fried egg. So Lucas and Ellie, you are 100% right when you told me that heat caused the chemical change to occur. So the raw egg, the fire, the final product was the cooked egg. The reactant, remember this, the reactant was the raw egg. When the raw egg hits the heat of the fire or the pan, a chemical reaction happens, and the product of this chemical reaction is the cooked egg. Now you have an activity sheet attached with the slideshow, and what you need to do, well done Kenzie, what you need to do is you need to cut out these pictures and you need to stick them in the correct column. One column is labeled reversible and the other column is labeled irreversible. So if you have a bar of chocolate, which is the very first picture on your activity sheet, and you melt a bar of chocolate, it becomes liquid. Who is going to put their hand up and tell me which column it goes to? Kenzie. I'm unmuting you, Kenzie, and there we go.
Yeah, it goes to reversible changes because you can freeze it and it will go back to hard chocolate.
Exactly, you can put it back in the fridge and it will become hard again. Let me choose somebody. Tarek, tell me what column you would put water in. So it seems Tarek has done it again, pretending to be online. This has been noted and I will be informing Miss Rachel. And just so you know, when you watch this back, Tarek, this lesson is being recorded and we have noticed once again that you are not online. Kenzie, no, not Kenzie, Jana, what column would butter go into?
Butter would go into irreversible.
Why do you think butter would go into irreversible?
Actually, the other one because you can freeze it. You can freeze it again.
Exactly. So it would go in irreversible.
Yeah.
No, not irreversible. Butter is reversible because once it's melted, it can be made a solid again. So I think we all have the idea of, oh, let's give Karma a chance. Karma.
Miss, I have a question.
Yes.
Is there egg cycle?
Is there what?
An egg cycle?
An egg cycle. Where does an egg come from?
Egg from a chicken.
It does. An egg comes from a chicken. So there is an egg cycle, and class did this just before you joined us. So I will send you some worksheets and some explanations on how an egg is made. Unless we have someone feeling super duper brainy this morning and wants to explain to Karma about eggs.
And I want to tell you something else.
Yes.
Tarek is writing that he doesn't have a mic.
Okay, well, I will check. He had a mic earlier and a video earlier, so if he puts his video back on, then people will believe he's there. Right, let's because I've just had a message saying there's 10 minutes left. After the 10 minutes, I will get somebody to explain to Karma the egg cycle. So, seeing changes, I have also provided you with another worksheet where you can talk about seeing changes, and you need to answer the questions on this worksheet. So I'm giving you also the opportunity to do a couple of investigations at home. Okay, they are fun investigations, things that you wouldn't believe. When you do your investigations, I love to watch you do them. So get somebody to film you and talk about what you are seeing that is happening. And all the investigations I am giving you to try at home are with eggs, okay? So you can try these irreversible changes by yourself. You will be making new materials. And after you have done these, there is a worksheet that I would like you to complete. So the first investigation I would like you to do is to mix milk and vinegar. Okay, it gives you how much milk you should be mixing with the vinegar. And in your video, I want you to explain to me what you have observed. What do you see has happened? So, I mean, this PowerPoint was made as if you've done it with me in school. So I'll talk you through it quickly. As you mix the vinegar with the milk, it begins to curdle. It begins to lots of little hard pieces, and it separates into clumps, into lumps of solid floating in thin watery liquid. So you need to strain, you need to filter the mixture to separate the solid from the liquid. So you will have a cup of hard stuff and you will have a cup of liquid. The solids you are left with are the new material. They are the product. And the chemical reaction has created a form of plastic. And this plastic is called casein. Okay, the casein plastic can be shaped and it can be left to dry. So you can make a little model. You have just made plastic and you can make a little model with this plastic, leave it in the sun, it will dry, and there you have it. You've got yourself a souvenir from mixing milk and vinegar. Next one. Casein plastic was quite common in the early 1900s until about 1945. It was used to make buttons, you know, buttons that you do your clothes up with. It was used to make buckles. So on the end of every belt, if you tighten your trousers with belts, you've got a buckle. Beads, beads on necklaces, fountain pens, those pens that you write beautifully with ink with, and the backings of handheld mirrors. For us ladies, who can be a little bit vain sometimes, if we have a mirror in our handbag when we go out and about and we pull it out and the back is plastic, it's made from that type of plastic that you have just made at home. And also combs and brushes. But you need to remember, casein is the protein that is found in milk. And an interesting fact is that the ancient Egyptians also used casein as a colouring for painting or as a base for painting to make it like paint to paint walls. And you don't need to know that fact. I've just added it in there just to make it a bit more interesting. I will answer questions as soon as I've finished because there's 5 minutes left. The next little investigation you can do at home is mixing bicarbonate of soda and vinegar. So use a cardboard cone. Get a piece of cardboard and make a cone, okay, like in this picture. And put 50 grams of bicarbonate of soda into a balloon. So attach the cone to a balloon. Then pour 50 milliliters of white vinegar into a plastic bottle. And then stretch the balloon over the top of this bottle. So the balloon you used for the cone, move it across to the plastic bottle, put the top over the plastic bottle. Don't let the bicarbonate of soda fall into the bottle. And then slowly lift the balloon up and let the bicarbonate of soda fall into the vinegar. And in your video, you need to be telling me what you noticed that happened. So carbon dioxide is a very useful gas. It is dissolved in liquid to create fizzy drinks. So when you drink your Coca-Cola, your Fanta, your Sprite, it's fizzy. And that's because carbon dioxide has been added. And carbon dioxide is also used to make food cold on aeroplanes and trains, but it is also used in fire extinguishers to help put out fires. So as you mix the vinegar with the bicarbonate of soda, they react with each other and they create new material. Carbon dioxide is what is created. It is the gas that causes the bubbles in the froth that you can see when you drink a Coca-Cola, the white layer. The carbon dioxide gas spreads out to blow up the balloon. So with vinegar and bicarbonate of soda, you will be blowing up a balloon. So there is no time to ask you guys these true or false questions. But finally, before I ask Luca his question, I have put a link. These blue words at the top are a link to some more experiments that you can be making or doing at home. You can cook an egg in alcohol, but please do not eat it after you've done it. You can make a green fried egg. You can eat this green fried egg. And you can make a bouncy ball with an egg, but you cannot eat the bouncy ball. Guys, I'm telling you now, do not eat your bouncy ball or your egg cooked in alcohol. And if you try any of those experiments, you don't have to, but you can, record yourself by video and send it to me. And finally, if you finish absolutely everything and you are bored, and I highly doubt this will happen, make a poached egg. Research what a poached egg is online, research the recipe, follow the recipe, and make your dad and mum some poached eggs for breakfast. Okay, if you do this, make a video clip of you doing this recipe and explain to me any chemical changes that you see happening and why these chemical changes are happening. You can even find the reasons and explanations online. Lucas, quickly, tell me, what's your question?
I just have a quick 2 questions.
Go for it.
First, well, not questions. I wanted to say that said, I was like, hey, you use that in Coca-Cola.
Yes, exactly. Kenzie, last question.
Yes, Miss. Actually, I can do a poached egg anytime because my dad knows the recipe, and I know how to do the bouncy ball. You just put an egg in vinegar.
Oh, there you go.
I've done it.
Fantastic. Do it again if you have time and show me. Any more questions? Nadeem, quickly before the line cuts.
Miss, we're in Ramadan.